Yeah, so we're actually going to start with the OOP design. So I have a question actually put in the chat. If you just joined, please read the question. I want you to read through this question and then, brainstorm for a few seconds. If you've done it before, that's fine. Open this question, then take a look and see how you'd approach it. I'm giving about a minute because some of you already joined the meeting earlier, so you've already taken a look at it. So please open this question, take a good look at the question, and then we'll go on to solving it. I just want to tell you something about it. So yeah, let's do that for the next 1 minute. Okay, let's start. So we're basically just going to solve this question, and we probably not solve the whole thing, but we just want to, just go through, get how the design pattern goes and everything. Can everyone see my screen? Can everyone see my screen?
Yeah.
Okay, so can anyone tell me what the question is asking us to do? Like what you got from it. You don't need to tell us the whole thing, but what like you got from it. So if you had this question in an interview or something, how would you approach it? Anyone? Anyone?
Hello.
Yeah.
Hello.
Yeah. You can go ahead. Yeah, John can go ahead.
Okay, so to me, what I'm going to do is looking at this question is quite. I feel it's quite simple to be medium, because it's just a dictionary, like I said. So for the first one, I think what I'm going to do is just to look into a dictionary and see if an item is there or not. If it's there, so if the item is there, you remove it. Okay, and you return a boolean value. If it's not there, you add it, return a boolean value as well. So it's basically very simple. I don't think it's very hard.
Yeah.
Right?
Uh-huh. And what about get random? So okay. Actually, what John said is right. So basically, as opposed to so actually, got this question like in an interview just like last week. And so when you meet a question like this in an interview, it's like there's no. I know some of you are very used to this template, right? Like, wait, can everyone hear me? By the way, can I be heard?
Yeah, I can hear you.
Okay, good stuff. So I know most of you are used to, this kind of template, right? Where you open LeetCode or something or HackerRank and there's this provided, thing for you. Like, the class is already written for you, the function steps are all written for you. In an interview, you are almost always never going to get something like this, right? So you want to train yourself in that pattern. When you open question like this, please reset everything, right? So that's the first thing to keep in mind, that you have to start getting comfortable with writing your own thing, like starting your own function name and using the right function name. So if it's add two numbers, you can like add numbers, something like this, right? Maybe num1 and num2. That is something that is very important. As you get to an interview and you've even forgotten how functions are written, right, in your programming language. Okay, so it says we should basically design, this class, right? And the class is called randomized set. In the interviewer was like, I assume you have a lottery system, right? And if for your lottery system, you're able to add, a participant. You're able to, also remove a participant, and you can also get a random participant in the lottery, right? Who has applied to the lottery, and do this as efficiently as possible. So you see, that's basically the question the interviewer posed. He didn't mention any time complexity you wanted. It was like, I want you to design this lottery system and make it as efficient as possible, right? So that means like, it's so open-ended and the decision is basically up to you. You have to make those decisions. What is efficient to you? Is it linear time? Is it quadratic? Is it, logarithmic? That is all up to you, right? So when you get questions like this, as I said last week, when you start reading the thing, so first of all, it's a class, right? So it's a system. So let's just write some docstring here. So I know I'm going to design, a certain system. Let's just call it randomized set, as they said now, randomized set, right? And then, it has to support some functionalities, right? So those functionalities are usually going to inform the data structures and algorithms you use, right? So the first functionality is that, okay, it should support insertion, right? And that is, you should be able to take a value and then insert it into your value. Then the first thing you do is that, okay, which data structure, right, is going to make insertion as efficient as possible, right? So you realize that you've learned data structures and algorithms, sets, lists, arrays, all these cool stuff, right? But then here you get to apply them, you get to make the decision. So you're being asked, if I want to have this data structure that will make insertion as efficient as possible, which one am I going to choose, right? So can anyone, before we do that, what's the time complexity for insertion into a set? What's the time complexity? Anyone?
It's O of 1.
Good. It's constant time, right? In an interview, so I've had a couple of interviews where the interviewers were like, "Can you explain why it is O of 1?" That's something we talk about today. But it's amortized, right? That's the right thing. It's amortized constant time. That means that it's not strictly O of 1, but there's some science under the hood, and that makes us assume it's O of 1. So now let's stick with the general O of 1. Okay. What about into a list? What's the time complexity of insertion into a list? Anyone?
I think that one
depends on where you put it.
Exactly.
O of n.
Good. It depends on where you put it. That is actually, the right answer. Like if I say linear time, I've generalized it, right, for a whole list. But when we did list and arrays, we are like, if you put it at the end, that's constant time, right? Like if I have 1, 2, 3, 4, right, and I'm like, put 5 at the end, I just put 5 here, right? We said the time complexity for the list, right, usually comes from whether you move elements or not. When I added the 5, right, I didn't move any other element. I just left it as it is. Now, as you want to add 6 to the first position, if I put 6 here, I have to move all the current elements back by 1, right, to maintain the indices. So that when I do index 0, I'm going to get this, right? So to maintain that indices inside a list or an array, when you insert to another place, you're going to move it. But when you insert at the end, you never move it. So that's constant time. So for a list, insertion at the end is constant time. But for any other place, we generalize it to be linear time. Very important to know, right? Okay, let's take any different data. What about insertion into a dictionary or a hash map? What's the time complexity?
Amortized constant.
Yeah, that's also constant time, right? Like insertion into a dictionary, just take it, just throw you in. Okay. What about insertion into a linked list?
Depends on where you put it.
Exactly. It depends on what and so it depends on the structure of your linked list, right? Like if I create a linked list and I have access to both the head and I have access, so if the interviewer asks you what's the time complexity of insertion to a linked list, right? You have to show like what you're saying, right? I'm like, okay, assume my linked list has access to both the head, right? Assume you have access to both your head and your tail. You're like, okay, in that case, want to insert to say the tail, that's constant time, right? I can just just link them, right? If I want to insert to the head, I can simply link them. But let's say if somewhere in the middle, right, I probably have to iterate the linked list till I get there, right? And then something like that. So please try to get these fundamentals of the data structures. That's why we're like, just, if you couldn't read a book, we went through all these things when we did, the speed track sessions on them. Try to understand them. Just sit down and ask yourself, what the time complexity of this? If you don't know, just look it up online or just ask in the, in the channel, and then someone will get to you. Okay. So now looking at, all these things we know, let's come to this first method. We want to, have this system that makes insertion as efficient as possible, right? So what data structure is good to use? Anyone? See, I don't want you to think of solving the question right now. Just answer the question. I want to make insertion as efficient as possible. What data structure do I have to use?
A set or a dictionary.
Okay, because we know a set is O of 1, right? We also know a dictionary is O of 1. And we also know that a list, if you insert at the end, right, that's also O of 1, right? So we know this is the best we can get, right? Let's keep these there. So we are like, okay, then let's go to remove. We go to remove. That one, we have a value, we want to remove it, right? So then you ask yourself, what data structure gives you very good time complexity for removal? See, we're not even thinking about the algorithms, right? We're thinking about the data structures for now. So if I want to remove from a set, what's the time complexity? A set, what's the time complexity?
That's
O of 1.
Yeah, that's also O of 1, right? And a dictionary too is O of 1 if you want to remove, right? It's actually O of 1 for those who don't know. It's a very interesting thing, but it's actually O of 1. So just put that in your head. And what else? What about a list? If you want to remove from a list, what's the time complexity?
Stack or something, yeah. That would
Worst
be
case,
like,
O of n.
Yeah, but it's O of one when it's also at the end, right? When I pop, right? When I pop, I just pop it from the end, and that's done. Else, it's what do you call it? Else is what? Linear time, right? So like once you remove this 5 and I just pop, I'm just done, right? Like I just move, I don't move any other element, so I'm done. Okay. So what other data structure? Linked list. What's the time complexity for a linked list? Removal from a linked list.
Also depending on what you want to remove from the
Yeah,
link
and the
list.
structure of the linked list. If it's a doubly
Yeah.
linked list, right? Assume this is a node and you have previous and next. You can simply, let previous next be this guy, right? Be this next. Let this next one to also be this guy, right? So if it's a doubly linked
Exactly.
list, it's O of one, right? Else it's linear. Okay, so let's keep these two for now, right? So you see,
Wait, I have a question there.
yeah.
Double link list. Yes. I've been thinking about it, trying to understand, because even with the double link list, I might have to traverse the node is in the middle. But then doing
If it's in the middle, you actually don't have to traverse. So
okay.
yeah, because assume you have the node, right? And assume this is your node.
Yeah.
Let's say node 1 is some node, right? Let's say A. And node 2
Yeah.
it says it's some node B, right? And let's say you have node 3, that is some node C, right? And node, this guy has node previous, so let's make it none. It also has a next, that is say node 2, right? For now, just assume this code that works, right? And this guy is previous node 1, and this guy's next is node 2. This guy is previous is node 2 and it has no next, right? If I want to remove node 2, so that's like I have something like this. Node 1 that connects, I have node 1 connecting to node 2, connecting to node 3. If I want to remove node 2, right? Your remove function will give you node 2. To remove node 2, all you simply have to do is to do node 2's previous is next, right?
Yeah. I got
Right.
it. I got it.
Yeah.
I got it.
So you can actually remove, in constant time. Good stuff, good stuff. So let's see. So you're actually making good progress, right? So we are like,
I have a question.
yeah.
What if the remove function gives you the parameter is the value instead of the node itself, the node address itself?
Good. So then there's something extra you can do. What you can do, that's a very good question. And there's actually a certain design question in that when you finish, you can try that question, LRE cache, right? It uses that thing you just said right now. Let's look at it quickly. So this is it. This is what we want to do. We want to remove, right? And in removing, we simply have access to the value. So the structure we use is that what you can do, look at it, is very smart. Just pay attention. So as you want to remove, right? So now assume that we have a certain system that stores it as nodes and not a value, right? That's basically the problem, right? Our system stores the data, as let's say integers. So we are given integers. The data gets integers as input, right? We add integers. Let's do it this way. We supply integers, right, to our system. But then under the hood, we store as nodes, right? As nodes. So something like, something like nodes like this. And then you want to remove it. What you can do is that you create a hash map, a map, where you map, right? Where you map the integer. So like, let's say 2 to its node like this. So if they ask you to remove 2, what you do is that you use your map and go and get the corresponding node, and then you do that removal thing we just discussed. Does it make sense?
Yeah.
Yeah, and that gives you your O of 1, right? So if you look at this, code here, somebody's trying to talk and the network. So if you look at this code here, right, this is my data, right? The key, if I want to add, that's put. What I create.
I also have a follow-up.
Yeah, go ahead. Yeah, the network was breaking, but can go ahead.
Asking, so does that mean it doesn't support duplicates?
Yeah, if you want to support duplicate, there's another thing you can do, but currently it doesn't support duplicate, and that's actually an extension to this question. So like the interview actually asked a follow-up question. Let's go through this question and we'll add that extension. Okay, so far we are doing really good, right? Like we've got constant time. You cannot do better than constant time, right? We've got constant time data structure here. We've got a constant time data structure here. You can do better than constant time. So we seem to be in good shape, right? Let's go to the last functionality. That is get random, right? And get random simply says that if I call this method, right? If I call this method, I want you to give me a random number from all the values I have given you, right? So like a random number from this sequence, right? So now you ask yourself, how can I get a random number from something efficiently, right? That's the question now, right? Or is there any function that exists that is able to give me the random version of something very quickly, very randomly, right? If you've been programming for long, you know that, in Python other things, we have the random, right? We have random. You can simply import from random. And then I know probably some of you are not familiar, but we have this random, then you can do like random.randint, right? That gives you, I think that takes like the starting index and the ending index and gives you a number in that range, right? And so on and so forth. But then, you get stuck. You're like, okay, so this one thing. So this is something we can use, right? So let's assume this guy returns an integer, right? An integer. Then you can then take that integer, right? And then maybe go and index something and then get it, right? So this is one thing. The other thing also is there's something called random.choice. And what random.choice does is that it takes, say, a list, right? And that also gives you a random number. So you realize that before you go to this one, everything seemed to be so cool and so fun, right? But you get to this third one, and then you're like, what data structure am I going to use? So you're like, can I have a set implementation that gives me a very good time? Can I have a set that, that can help me solve this thing very fast, this thing very fast? Or can it be a dictionary that helps me solve this random very fast? Or can it be a list that helps me solve this thing very fast, right? That's basically the thing you get to. So the thing with design question is, if you have the question, I would say read through all the various, all the methods, right? Because usually the first few methods are kind of like manageable, right? But you get to the third one, you realize, oops, the things I was thinking of does not really, does not really fit the problem statement. I need to combine a few more things, right? So for now, I just want you to, put a random one in your head. I'm going to first give you that one, and then we basically then revise the first two we said, right? Because
I have a question.
John, go ahead.
Yeah, so looking at the get random, I was just being lazy and I'm like, let me just return the first value to them.
No, that's wrong. So the reason you can't return the first value is, if you return the first value, it is no longer random, right? It's deterministic. That means anyone can just guess. Assume we're using this thing to create a password or something or play a game, right? We are like, if you're able to guess the number, we give you $10 million US. You go bankrupt, you go broke, everybody will win your money, right? Plus, this says each element must have the same probability of being returned, right? That's the probability of every number is 1/n, where n is the number of
Yeah.
So you'll be violating that condition. So the trick, this question becomes difficult when you get to the get random part. And the get random is very simple if you know this thing in Python, like random.choice or random.randint, and then you index it. But you know that if you decide to use random.randint, so what I can do with random.randint is I get a certain number from the range of 0 to the length of the list, right? Now just, go and index it. But then ask yourself, which data structure allows indexing, right? That's like a list. That means, okay, then let's keep a list, right? Let's keep a list, right? Then that means that the data structures we came in with looks like the list is winning at this point, right? I'll go to the next one. You're like, I want to use random.choice. That also takes a list, right? And then that means a list definitely has to be kept. So you know that we definitely need a list, right? We definitely need a list, at least for random. Does that make sense to everyone? I know you probably didn't. I mean, some of you might not have known these ones, but then you realize,
we need a list, but then I can still keep the set or maybe dictionary and convert it to a list anytime I need it, right?
No, but if you decide to convert it each time, it becomes linear time. That means that your get random becomes linear time complexity, right? If you decide to keep, let's say, a dictionary, and then when get random is called, you're like, let me convert my dictionary or my set to a list, and then find a random, that becomes linear time. Because converting a set to a list is linear. Let's loop through all these ones and create a list out of it. So that is inefficient, right? So the solution to this question, the algorithm is so pretty, right? And we have all the information we need. We don't need a set. Why don't we need a set? Well, whatever a set can do, a dictionary can do it, right? Because see, a set is simply a dictionary with no values, right? Like that's what a set is. So a dictionary is something like this, right? A dictionary has key value pairs, right? A set is simply a dictionary with no values, right? So that's like, we just remove the values and then the keys become the value, right? So anything you can do with a set, you can actually do with a dictionary, right? That is one thing, one reason why we don't need a set. The other thing we don't need a set become obvious when we're actually solving this question. So now we have solved, let's clean this up. Now we have solved get random. And we know get random, we can simply do return random.choice. That's literally the solution, right? Then our list, let's just call it self.list, right? So we have solved get random. So now let's come to solving the other questions. Let's come to solve remove. Now we know that, so let's try to solve remove. I probably should write at this point. Well, let's just code it out. Let's just write the code here, def remove. Then we're going to be given a value. Let's write self here, doing a value. Now, how can we implement remove to get efficient time complexity? How can we implement remove? Anyone? So note, we need a list. We definitely need a list, right? Because of our random. Let's just write it as this random. Right, so how are you going to implement remove? Anyone? We already have some information about remove here. Let's put that here. How do you think we can, we said there's a way to get O of 1 for remove. And knowing that we need a list, how are you going to implement remove? Anyone? Note, we need a list. We need a list. And the list must contain all our items, right? So that this function will work perfectly for us. So now how do we implement remove? Realize the question is not simple. Yeah.
What I'm thinking is probably since we need a list, we can add another data structure that would enable us to actually do the remove efficiently, like maybe the dictionary as we were talking about.
Yeah, good. So that's actually it, right? So we know that we need a list, right? But then you realize that we know that a list, remove from a list is only constant time at the end. Right? Sorry, let's do insert first. I think that makes more sense. Let's do insert first, right? And insert, we are like, okay, for insert is the same thing, right? Like, let's just copy this. Let's do insert first. Okay, so you're like insert, right? A list, insertion into a list is only constant when it's at the end, right? And I know I need a list. And the elements of my list should be the same as the elements I've inserted throughout, right? That means that I always have to insert at the end, right? So I'm like, I have to insert at the end. So self.list.append my value. All right, that's what I'm going to do. That is just it. But then I need to also insert into my dictionary, right? I need to insert into my dictionary. Now I'll explain why we need a dictionary too. So then let's just do self.map. Let's call it map, right? Of the value is equal to, for now just say self.size. I'll explain what size is later, right? So this is basically what we have for insertion. Now let's go to remove. See how we become so smart here. Def remove. We're out of time, so I have to go through very quickly. For remove, see what we're going to do. It's so pretty. So let's assume you have these numbers in, right? Right. And then please pay attention. If you got nothing, at least follow this. See, when I first solved this question, it was when, like 2021, I don't remember, like 2022, right? And the algorithm was so pretty, right? I'm not kidding you. Just pay attention. Okay. Look at something. Now you have something like this, right? And when you inserted 1 in, assume the size of our list was 0, right? We had only 0. We had no element, so we put 0 in. Then when you put 1 in, 1, right? So you can think of it also as the indices, right? You can think of it as the index. So you can think of these as the index, right? So these are basically the index. So in other words, when our list was empty, then we inserted 1. So 1 is index 0. When we put 2 in, our list was empty. But each time you insert, you increase your size by 1, right? That's basically what's happening here. So please, if you don't understand, make sure you pause me, all right? So that you go over again. Okay, so assume you have something like this. Okay, you have something like this. Now let's see how we're going to remove. So this is the structure of our system. This is how we do the insertion, right? You append it to the list. When you append it to the list, right, then you put it inside your map as a key. Then let the value be, how many elements were in the list when you inserted, or how many elements, or basically the index, anyhow you want to interpret it, right? See how we can do the remove. So smart. Now you know that removal is constant only when you remove from the bottom, from the last element, right? So what we do is that you also know that the indices, or the positions of all the elements in the list, right? So assume you want to remove, let's assume you want to remove, say 3. You want to remove 3. So smart. All you need to do is find the index of 3, right? So let's call it 3 index. Right, find index of 3. And how do you get that? From your hash map, it easily gives you the index of 3. Note that even for an index of 3 from the list, that's going to be linear time, right? Because that's to start. Are you 3? No. Are you 3? No. Are you 3? Yes. Right? It's searching through the whole list. But with the hash map, it's constant time. You are there. Okay, so 3 index is 2. We get that, fine. Then the next thing we do, right, is find the index of the last element in your list. Getting the last element in the list is very simple. It's just also constant, right? Can simply do self.list index -1, right? Like this constant time. Just look at the back of the list, right? So let's call it a 6 currently. So let's call it 6 index, right? And that is index. We didn't put 6 in, so 6 What did I do? This is 4 and 6 is 5, right? So what you do is that first, find the last element. We said you can, that's constant time, right? That's self.list index minus 1. So we know that is 6. Then find the index of 6. That is also simple, right? From our hash map, that will also give us 5, right? That is 5 here. Then look at the next thing you do. Then, so we know the index of, we know these two things. We're looking at these two things. Then swap their positions in the list. You just have to swap them. Swapping is once again constant time. So let's write it now. Swap the value. So let's call this value. So swap the positions of value and the last elements, right? And the last element. So that is also constant time, if you can see. So self.list, right? Self.list 3 index. So that position should simply be the last value, right? And the last value should now be 3. So I can swap everything on that line by saying self.list in the 6 index. Let's just call it last index. I don't write much code, so it doesn't look a lot to people. So let's just call this val index. No, I'll walk over it again if it's confusing someone. I usually don't like to write like code, like when I'm explaining, so it becomes common, especially to those not using Python. Let's make this last index. Let's make this val index. Let me explain this code. So basically what we are doing is, we are like, okay, take the last, right? So we know the last value, right? This is the value index. That's the index of the last of the value, right? That's 3. The value we want to remove, that's 3. We know its index from the hash map, right? That is 2. Then we know the index of the last element, right? That is also 5, right? So we've stored the indexes here, val index and last index, right? We have those two things here. Then we're like, okay, get the value at that value index, that is 3, and get the value at the last index, that is also 6, and swap them, right? So now our list becomes something like, so look at what our list becomes. Please look here, I'm here. So our list becomes something like this. Put the 6 here, and then put the 3 here, right? Can you see it? So this is the state of our list now. Let's copy this. So our list looks something like this. So this is our list now. Can everyone see it? Now realize that that value you want to remove is at the end now, right? It's at the end now. What's the time complexity of removing from a list at the end? It's constant time, right? So I can simply do now my list self.list.pop, and this is constant time. Have we not solved the problem? That's it. So what do? When you do this swap, you should update this dictionary too, right? Because now 6, right, is at index 2, right? So now I'll just update 6 to be index 2, right? Updating a map is constant time. Why can time complete for deleting from a list? That's also constant time, right? We said it here. What was it? Yeah, we said it. So in this one, you can also delete, and that's constant time. Does the algorithm make sense? Does it make sense?
Oh yeah, quite interesting. The swapping aspect of it.
Yeah, it's very smart, right? Like just swap the elements. So the one that you want to remove, all we are trying to do is to bring you to the end, right? Because we know removing from the end is constant time, right? So you see the hash map was good for finding the positions, for finding the indices, right? So use the hash map to find the position where you are in our list. Then we swap you with the last element, right? And then we just pop you. That's also constant time. And that's the solution to the problem. Let me just open this briefly. I don't think we can do the the actual system. Wait, let me just paste the solution here. Oops. Let's copy this. Okay. So if you look here, so this is what we have here. So with initialization, right, we're going to need both a map, that's a hash map, that's going to contain integers. The values to be integers. Then we're going to have a list, right? Or I'm calling an array here. Let me just call it list. Okay. And then we have, the length of the list, right? At the start is 0, right? If I want to insert, right, all I do is that I append it to the list, this constant time. I put it inside my dictionary, that's also constant time. Then I increase the length, that's also constant time, right? If I want to remove, what I do is that I find the last element, right? This is also constant time. Then I find the index the element I want to remove, right? Index I want to remove. Let me just call it val index, right? The index I want to remove. Let's even put that here. Okay. So I find the index of the value I want to remove, right? It's in my map, it's my dictionary, right? And I find the last index, right? And I just swap them. You can literally just override it by just swap them here. So now the index I want to remove is at the end there. Then I can pop this constant time. I can delete from my hash map. This is how you delete from dictionary in Python. Just write del, then the name of the dictionary, index, then the key you want to remove, right? That's also constant time. then decrease your length by 1, then just return to it. Get random, just use random.choice, and you're done. And that's the whole problem. That is everything.
Yes, I have a question.
Yeah.
Is it advisable to use the delete, like when you are being asked to like remove something from a list, or like it's better to swap? Because when you delete, what happens to the list? And I
Yeah,
want
so-
to know, like, if it's advisable, like
Yeah,
in terms of memory and all of that.
Yeah, so this deleting is deleting from a dictionary, from a hash map, not from a list, right? If you delete from a list, it is only at the end that it is constant time. If you delete from anywhere else in the list, it's linear time, right? So if this is my list, like 1, 2, 3, 4, 5. If I delete from here, it's linear time. This is linear time. If I delete from here, it's constant time, right? So if I delete from a list, delete from the end, right? You see, that was why we were trying to achieve. We just wanted to, we know deleting from the end is constant time. So the whole problem was, how then can I move that element onto delete to the end, right? To the back, right? And that is what we're doing. But deleting from a hash map, from a dictionary, right? That is actually constant time. So for that is efficient. Can you delete from your hash map by just doing del, that's delete self.map, then the key is that, right? This is it in Python. For the Java people, I have no idea how you write that. Actually, that's a funny thing. I had an interview like recently, and I started the interview, and then the interviewer asked me, Java or TypeScript? And I'm like, bro, I'm on Python. And it's like Java, and I'm like, okay, you give me Java. Yeah, I actually did Java. And I get to this part where I've written my Java code, feeling so proud of myself. And I'm supposed to write a for loop, right? This was so funny. And I'm like, it's been so long I wrote Java, right? He's like, don't worry about the syntax. And I'm like, okay, thank you. So I'm supposed to loop through the entries, right? And I remember Java has something like object.entries or something, or JavaScript. I don't even remember, right? I know like,
Java has
Java, right? Then I do this, right? Then so I want to destructure, so I get the key and the value here, right? Then I'll do like object.entries, bro. Come and see me. Then I'm like, let's just assume we have a tuple, key, comma, value. But yeah, well, they moved me on, so that means I wasn't that bad. So yeah, so that's what I tell people, right? If you pick Python up and you get a chance to, pick another programming language, like pick a typed one, pick up Java or pick up C++ or pick up TypeScript, right? But I'll say pick Java. I think Java is friendly, honestly. But it's been like years since I coded in Java.
Java will be fine.
Yeah, but I still remember some new hash map and stuff here. And then when you learn multiple programming languages, they become some way, but it's so easy to pick up. Yeah, so that's the solution to this question. We didn't solve it, please. Yeah,
Cornelius,
yeah.
I have a question with like the solution that you
Okay, let's
showed
go
before.
back. Yeah, let's go back to it. Give me a second. Okay.
Yeah, so like I'm looking in the remove in the remove function, and I think I don't see where like you set the like reset the map to like this one, the new index. So like was that like an optional thing, or
Oh, right. So you realize that, you mean like the value I'm removing, like changing its value?
yeah.
Oh, for that one, it because I'm deleting, right? Like I'm deleting it, so I don't need to set its new value.
Okay.
Okay, so I see what you're trying to say. Oh, see this line. This line is doing two things. This line is both setting the new index for the last element, that is what, in the list, and it's also setting its position in the map, right?
Okay.
Element we're removing, we don't care about its new information because we're removing it, right? Like I mean, I could have broken this thing into two, right? And done first, right? Let's change val index, right? And last element, right? Let's change. I call it last index, right? Let's swap these. So this is like swapping in the list, right? Swapping in the list. After I'll do swapping, I'll do the same thing. I'll be like swapping in the map, right? But here instead of list, right, this becomes map. So I'll be like swap in their list and swap in their map, right? So swap in map or our dictionary. Then here is swap in the list, right? We realize that for the value, right, for the one we're removing, we don't care about like its information, right? Like we don't care about it at this point because we're removing it, right? Does that make sense?
Yeah.
Yeah, so that's why you see it this way. Yeah, I think when I first solved this question, actually, I cared about that guy. Let's see, when I first solved this one, right? That's a funny thing. See, I didn't write this code, and it's because it doesn't look like how I write code. Like when I first solved this, I couldn't actually solve it. So I learned the solution from somewhere. Yeah, I don't think I saw this code. This doesn't look like my code. Right. So if you look at this code here, what the person do? Oh, the person copied me. Yeah, stuff like that. So basically, yeah, that's it. Yeah, we're a bit behind time. Please solve this question, and we released a couple of problems for folks to go through. Let me just open this one. Okay, and then we released some problems for you to go through. And I told you, even the question Fred actually posted, a friend of mine had their Microsoft interview just last week, and they got the same question, test editor. What is it? Yeah, like Fred posted like this question here, like this one, the person actually had that question. And yeah, and then we also shared this list. Please do want to go through these, like they're so important. They're so important. See, when you start a question, see, the thing is, I've been telling my friends, like no one expects you to open Design Head Counter and solve it perfectly. Like it really happens. Like me, as dumb as I am, I still can't solve many of these things, right? So what you do is that I open this question, right? I think I'm like, okay, this is not working. I try some code, I'm using, time complexity is not, as good enough, but they want O of 1, right? What do? I go to YouTube. Okay, this is a premium solution. That's fine. I tell people if it's premium, that's not the end of the world. Just go to solutions here, right? Then all you do is that you do sort by most votes, right? Then if you use Java, you're lucky. Like that's the first one, right? If you use Python, just select the Python 3 parts, right? Then pick up someone's solution right here. Sometimes see, they even do you well by explaining the thing to you, right? Scroll down, look at their code. See, they even add comments, bro, without you paying them. Then you read the thing, you understand, and then what I do sometimes is I just copy it here, then I paste it in mine. So see, I showed you like the first one, I was like, I didn't write this code, right? Because like I know when I write code, I'm like, that code wasn't mine. Just paste it here, try to study the code, make sure you understand it. Maybe it's not clear, go to YouTube. So simple, right? Like just go to YouTube, go, even the same question, like Neat Code even has a solution on it, right? Like we can just paste this here. Get insert, get random. I don't even know what's going on here. Lead code. The first one is supposed to be removed. But right, just watch this video. Take your time, please. Watch this video. Make sure you understand it. Once you think you have a good grasp, when he's explaining, do well to understand. When he gets to the coding part, right, like you explain, then you begin to code. Code along with him. Make sure you understand whatever line of code he writes. When you're done, submit. Go on to your next question. After 2 or 3 questions, come back to this question. Try to solve it again on yourself from scratch. Like it's so important. Revision is so important. Some of you have solved like 200 questions, but if I give you like the same question, you're not going to be able to solve, right? Because we don't revise. We're not robots. Please revise. I tell people when I have an interview, right? As I have an interview like on Monday or on Wednesday, I don't try solving new questions for the most part. I revise all my solved questions as much as I can. Right? Like revision sometimes won't take time, right? Just open the thing, try to solve the thing again, right? You get stuck, you're like, oops, I didn't learn this thing well. Go and check the solution again and on you go. So those of you who have solved many questions, please pause, go back and revise all those solved questions. Like there are thousands of questions, right? Like it'd be so painful if you go and you see this question you've done before and you go and you fumble, right? I had done this question before. So when I had it in an interview, there was something funny actually. See this algorithm, this smart part, right? And I'm like, so how am I going to do this? Right, I was pretending as if I'm thinking. I'm like, don't worry, I know it. And I just went ahead. Like you come across these situations, right? Wait, like you've done a thing before, right? Then you put on some acting. But yeah. So please revise, like revise. I revised it, like see. I actually redid it. So you see, I did this in September 2022. Then August 2023, August 2020. That's like last month, right? I redid it again, right? And I revised it last week. That's the interesting part too, even before the interview. So please. It is so crucial. Make sure you revise. It's not in the numbers, it's in the quality. Okay. I wanted us to do system design, the other one, but we can't. But I'm going to give you an assignment. Please, assignment 1, revise or solve problems. I don't care whether you have an interview coming up or an OA or anything. Please revise. When you're done revising and you have an OA or something and you want company-specific questions, just let us know. Like we have this. So this question we just solved, in the past 6 months, these are the companies that have asked. Like Uber, Bloomberg, Amazon, Facebook. If you need this information, just request it and we'll give it to you. Like if you want commonly asked questions for some company, that's something we can easily give it to you, right? But please revise. When you're done revising, you can solve the company tagged questions, right? And then it should be good. And then for the system design, especially those who are recruiting for new grad, I would say one key thing that helps you with system design is build stuff, right? Like build simple APIs, build simple front ends, let them communicate, right? Learn a bit about databases, right? Use some, some relational database. Try to, when you build a backend, you definitely need some database, right? Unless you're always using APIs. Please don't always be using third-party APIs. Try to build your own, you use your own database. Try to, store data in your own database. Maybe you only use S3 packets or something, or Postgres or something. Do that, and God willing, next week, we will try to start some system design. I feel like we've done a lot of DSA and stuff. If you're ever going to go back to these things, it's maybe some topic we've not tackled, or just some live problem solving like we did today. I mean, that one, you're putting things in place that